Here's the Algebra 2-4 Rational Expressions Test Review, but it's the second page, so I'm starting at number 11. We have a fraction equaling another fraction, so we're just going to cross multiply both directions. So we have 3x equals 2x minus 6. Be sure to distribute this 2, so it's 2x and then a minus 6. From there we're going to solve, so I subtract the 2x, and x is a negative 6. That's it. Moving on, looking at the next one. It's not as quick and easy as this one. This time we have two fractions on the left-hand side. We have to get common denominators before we're allowed to cross multiply. So over here I'm going to multiply by a 6, over here an x plus 2. And I'm going to go ahead and FOIL over 6x plus 12 plus x plus 2 over 6x plus 12. So I'm focusing on getting common denominators. I have, so I'm going to add the top, and I get x plus 8 over 6x plus 12 equals negative 1 over x minus 3. So here you just combine like terms. X is by itself, 6 plus 2 is 8. Then we cross multiply. I get negative 6x minus 12 when I go this direction. When I go this direction, you have to be a little more careful. It's x minus 3. It's x minus 3 times x plus 8. So we have a binomial times another binomial there. We're going to have to FOIL. So this is negative 6x minus 12 equals, we FOIL, we get x squared, an 8x, and a minus 3x, so a plus 5x. Negative 3 times 8, negative 24. Now, we're going to have to solve this a different way. We can't just get x alone because we have an x squared, an x, and then we have a constant. So we're going to move everything to one side. So I'm going to add this 6x, and I get an 11x. I'm going to add this 12, and I get minus 12. Why do I do that? Well, when you have an x squared, an x, and a constant, we're going to have to solve, okay, like it's like a quadratic where we have to factor or do the quadratic formula. This one factors to x plus 12, x minus 1, giving us our two answers. X is negative 12 and a positive 1. Moving on, number 13. 13 is just as easy as number 11. You can think of that as over 1. You're going to multiply. We get x squared minus 4x. When I go that direction, all of that equals 32. When you get to this step, now it's back like problem number 12. We have an x squared, an x, and a constant. So we're going to move the 32 to the other side. We have this. We're going to factor that. And then we have x equals a positive 8 and a negative 4. Two answers again because we ended up with an x squared. I'm actually going to skip number 14. It's a doable problem, but there is an error in it, and we won't see that on tomorrow's test. So we're just going to ignore 14. We're going to look at 15 next. 15 and 16 are inequalities, so we solve them a little bit differently. We're still going to cross multiply. In this case, it's really important to make sure you put it on the right side. So x is in the numerator, we're going to leave it. This is 2x minus 1 times 1, and it needs to go where the numerator was, so up here on the right-hand side of the inequality. From there, you solve it. So I added 1 to the other side. I've subtracted the x. I'll write my steps. I've added 1, and I've subtracted x. That's your first critical value. It's your first number that you need for your number line. The second number comes from the denominator, and you ignore all this. Go back up here. This is your denominator, and you don't want that to be 0. You solve. X cannot be 1/2. So 1/2 is a number, and 1 is our number. And those are the ones we're going to put on our number line. The half is open. The 1 is a closed circle. Then we're going to test a couple numbers. So over here, I'm going to test a 0. Over here, I'm going to test a 2. In the middle, let's just do 3/4. Those are just like test values when we're graphing, and you put them up in the original problem. So we're going to put them up here. What do I mean by put them up here? Well, we're testing to see where to shade. So if I plug a 0 into the original equation, I get 0 is less than or equal to 1. Is that a true statement? Well, yeah, 0 is less than 1. So I'm going to shade right here where that point worked, and I shade this whole side. And then I plug in the 3/4. We're assuming it probably won't work, because if this side works to the left, then we usually have to the right that works as well. I always test them all to make sure I didn't mess up. So we have this. I'm just going to use my calculator to plug it in. $1.5 is less than or equal to 1, not a true statement. So that one doesn't work. So then we plug in a 2. And we get 2/3 is less than 1. Totally true statement. So then this is shaded as well. And then we have one more step to do. This is an or statement. So you write the word or. Your shading is the letter X. So you say X is less than 1/2 or X is greater than or equal to 1. And we have to put a statement, one for each side of the graph. So 16, we're going to do it the same way. We're going to cross multiply. Then we're going to solve. And our first critical value, our first number is 3/5. The next one comes from the denominator, which is 3x. So x cannot be a 0. So we have 0 and 3/5. In this case, they are both open circles because neither of them are equal to. From there, we test critical values. -1, this is 0.6, so you can try a half here, 0.5, and then the number 1 to see what will work. When you go through and do that, you see that 1/2 works, the other two don't. So we have a different situation where it's shaded in the middle. When that happens, you write x, and this is saying x will be in between 0 and 3/5. If it was a closed circle, I'd put an equal to here as well, but it's in between. So you need the graph and the statement. Okay, almost done. Number 18. The word directly tells us y equals kx. Okay, if y goes up, x goes up. If y goes down, x goes down. And we look right here. Here's our first set of information, and it's a pair. So we're going to plug that in to our formula and see what that helps us find. Well, it helps us find k, because we're given x and we're given y, and we're plugging them in. You're going to divide by 6, and you get 1/12. So repeating decimal, so you cannot use a decimal here. Once we find that, we're going to use k to do this next part. It says find y. I just figured out what k is, and x is 10. So y equals 10/12, which we know reduces to 5/6. So y is 5/6. Inversely is different. It means if y goes up, x goes down, and vice versa. So the formula here is k is in the denominator. Here's our set of information. So 2 equals k over 25. Well, multiply by 25 and we get k to be 50. We use that for the second part. We don't know y. We know x is 40. We figured out 50 is our k. Reduce that and we get 5/4. Okay? On the next problem here, you always want to find that word that tells us how does it vary. Well, the word's inversely. Whatever comes before inversely is your y. So our profit here is our y. Whatever comes after the word inversely is our x. So cost is x. So it gives us this information right here and says profit is 2,000. That's your y. Cost is 500. That's your x. If it's inversely, it means 2,000 equals k over 500. You're going to multiply and you realize that that's 1,000,000. So k is 1,000,000. Come over here. It says find cost. So I'm actually trying to find x this time, not y. So I know what y is because that's my profit. So I have 5,000 equals 1,000,000's on top. That's my k. And I don't know x. So x is in the denominator. I'm not quite sure of it. Now, this is why we've been doing rationals with this. You can put a 1 underneath here and just cross multiply. And when you do that, you get 5,000x equals 1,000,000. Well, when you do that, then you divide and you get x to be 200. So 1,000,000 divided by 5,000 is 200.